Hello everyone. For the senior design project, our team has been working on brain-computer interface. Our team consists of two people, I, Sagar, and Shivchandar, and our project advisor is Professor Ann Carvilescu. Each year in United States, around 2 million people suffer from traumatic brain injury. People suffering from this injury have many cognitive and physical disabilities. People who have physical disabilities cannot move their hands or legs, and in some cases they cannot do any muscular movement at all. So the purpose of this project is to enable such people use computer just using their brain activity. To accomplish that purpose of ours, the goal that we have made is to make an interface that can convert the brain signals into machine level commands, and the users can then use these commands to perform regular activities on the computer. As you can see in this image on the left hand side, this is the computer which is connected with this sensor that sits on the top of the head of the user, and then this sensor records the brain spikes or the brain activity. And using the brain activity, this matrix simulates a click on a specific cell of the matrix. That is what it is using. What it is using is called brain-computer interface. As a matter of fact, one of the greatest scientists, Stephen Hawking, was also using this technology to record his lectures. Project description. As I've mentioned earlier, the goal of this project is to build interface, and we have divided that goal into two parts, hardware and software. The hardware part includes EEG caps with electrodes, and these EEG caps with electrodes would be used to collect the brain signals. These electrodes are very sensitive to the electrical activity of the brain. Whenever there is a spike or any major activity in the brain, these electrodes record that activity. The software part includes MATLAB toolbox that is used for training the machine learning model and analyzing the data collected. And then at the end, we are going to use a CAT toolkit to perform machine level commands in the Windows computer. This is a raw diagram of how our project is going to look like. There's this user, and then we are going to collect the EEG signals or brain data, and then that brain data is going to go through feature extraction, classification, and many other things. And at the end, we are going to get the machine learning model that we can use to carry out several commands in the computer or just run simple applications in the computer. User stories. As a user, I can use brain signals to use mouse cursor to navigate the desktop. The mouse cursors would be simply be used as the normal person would use in a normal desktop. Manage files on the computer, which includes copy, move, and deletion. Manage applications such as Acrobat, MS Word, and Notepad. These three applications would be primarily used to write something. And the most important thing we have in this section is web browsers. Just using the brain signals, users would be able to use web browsers, write a URL, search for anything, or maximize the windows, just as the regular person would do. And fourth is a virtual keyboard that includes text prediction, Google search, Wikipedia search, etc. The user who is going to write anything using this keyboard would be able to Google search and Wikipedia search right from the keyboard. And fifth is text-to-speech translator. The user who is going to write something in using these three applications would be able to use one feature, this text-to-speech translator feature, which would be simply translating text into speech in order to converse with other people. And last one is changing the input mode. The user should be able to change the input mode, although primarily we are focusing on EEG, or in other words, brain signals, but we have left this choice open for the users to be able to use other input modes. The visual mode would include something like motion of eyebrows or motion of eyeballs, and many other things. And auditory simply would be voice commands. These are the design diagrams we have. So the first one is very overall diagram. These are the users. They are going to interact with computer using BCI, and then this computer is connected with internet to back up many applications and many useful features for us. And this is a more granular version of the design. These are the users. These users are going to use EEG, and these EEG signals would be then input as a would be used as an input to this interface, which this interface here is going to convert EEG signals into ACAT compatible input. And then ACAT compatible input commands are going to be used in this Windows machine to carry out regular tasks and to open many applications and run them. Project constraints. One of the biggest constraints is the state of the user, brain state of the user. The user who is using this interface needs to be in a relaxed or a normal brain state. The user should not be nervous or anxious, because if he or she is, then this is going to increase the noise in the brain signals, and the machine learning model wouldn't perform really well. The second is data loss. As I mentioned, the noise reduction algorithms, when we use noise reduction algorithms, in most cases, some of the valuable data is also lost. And there have been many research going on in this field to figure out something that can be really useful and have a really good data. EEG cap position. So the cap that the user is going to wear needs to be in a stable position and in a fixed position. And lastly, the application compatibility. Not all the applications in the Windows desktop might be compatible with ACAT toolkit. This is how our project progress and timeline looks like. All the flags in green are the ones that we have completed, and in the gray are the ones that we are going to work on in the next semester. So far we have researched on EEG. We have done thorough research on brain-computer interface and how the data is collected, how the data is used. And then we also experimented with some hardware and software. We figured out which ones would be the best to use and which ones would be the best to solve a specific problem. We even downloaded many of these toolkits and software and then experimented with them. And lastly, most recently, we have created an overall design document that includes user stories, design diagrams, and many other useful things. Expected accomplishments. So by the end of this semester, we are expected to have all of the useful data collected, all the machines and hardware set up with equipment testing done, and full project documentation, which includes user stories, how different things are to be installed and set up, and designed documents, and several other things. And lastly, prototype. For the expo, we are hoping to have a simulation because it will be quite hard to move all the equipment from one room to the expo. So most probably it would be a video or a simulation describing every single thing that a normal user would do. And lastly, if there are any questions and comments, I would greatly appreciate. Thank you.